So solving systems of equations, systems of linear equations by graphing. There's 3 different methods to solve a system of, and I'm going to add in the word here, 2 linear equations. The first method is by graphing. So the way we would do this is that we would graph each line, and then the solution is the point of intersection. So wherever they intersect, that's going to be my answer. So let's do, the system is first equation, 2x minus y equals 1. And then the second equation is x plus 2y equals negative 7. Okay, so let's graph each of these. And I'm going to try to be as accurate as I can, because it's very important with these, so that when we find that point of intersection, we get it exactly right. Ideally, if you use graph paper, that's the best thing to do. So let's see what happens. So how about with this first one? Well, I'm going to pick the 2 different main methods of graphing. For this first one, 2x minus y equals 1. I'm going to solve for y on this one. I'm going to add y to both sides, and I'm going to subtract 1 on both sides. So the y's cancel, the 1's cancel, so that I get y by itself on one side, and then I have 2x minus 1 on the other side. So now I know my y-intercept is negative 1. So I'll start there, and then I'll use my slope of 2 over 1. So I'm going to do this in blue. We'll do this one in blue. So I'm going to start at negative 1, and then I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Okay, and also if you have a ruler of some sort, that's good to get this accurate. Okay, so there's my first line. I'm going to pick up purple for the next one. Next one, x plus 2y equals negative 7. So the first one I did slope-intercept form. This one I'll do my intercepts. X, y, 0 and 0. So if y is 0, this part's gone, 2 times 0 is gone, all I'm left with is x equals negative 7. If the x is gone, I'm left with 2y equals negative 7. Divide by 2. So I get negative 3.5. So my x-intercept is negative 7. 1, 2, 3, 4, 5, 6, 7. And then negative 3.5. 1, 2, 3.5. Let's see, hopefully I can get this pretty accurate. So it looks like where they intersect is at, let's see where this looks like. It looks like at maybe negative 1, negative 2. Looks like it's somewhere between negative 2 and negative 3. So it looks like maybe a little closer to negative 3. But this is where now, and this is going to be true all the time, but especially here, we need to check this. Let's do a little check. Go way over to this side. So is 2 times the x value I found is negative 1 minus negative 3 is that 1. Negative 2 plus 3. Yes, that one checks out. They both have to work though. So how about the second one? Negative 1 plus 2 times negative 3 is that negative 7. Negative 1 and negative 6. Yes, that's negative 7. So since they both work, then I know I got the right solution. Negative 1, negative 3 is where they intersect. Notice too that that's the only point where both of the lines have that point. So I've got the blue line for this top equation. Every single point on this line is a solution to the first equation. And then for my purple one, every single point on this line is a solution to this equation. But the only time where I get a point that's a solution to both of them, blue and purple, is right at negative 1, negative 3. So that's the only time that I'm going to get an x and y combination that's going to work in both.